Electrical currents flowing through Tate fixtures can induce a voltage in nearby electrical conductors, such as the wiring in a radiator. To mitigate this, consider using shielded cables or installing ferrite beads on the radio wiring to reduce induced currents. Tate fixtures can emit electromagnetic radiation that can interfere with the radio's reception. In this case, install electromagnetic interference shielded ballasts or use fixtures with built-in electromagnetic interference shielding. Electrical noise on the power lines can also cause static in radios. Implement a power line filter or surge protector on the circuit feeding the Tate fixtures to address this. Improper wiring or grounding can create ground loops that introduce electrical noise into the system. It is important to verify that the wiring and grounding are correct, strictly following the manufacturer's instructions. Some ballasts may not be compatible with Tate fixtures, leading to electrical noise or interference. Therefore, use ballasts specifically designed for the fixtures being used. Turning off all other electrical devices in the area can help isolate the source of the static. Check the strength of the radio signal before and after turning on the Tate fixtures to determine if they are the cause of the interference. Consider using light-emitting diode fixtures instead of Tate fixtures, as they typically produce less electromagnetic interference. If grounding and bonding have been verified and these solutions do not resolve the issue, it may be necessary to contact an electrician or a radio interference specialist for further assistance. Let's delve deeper into each of these points. Firstly, induced current occurs when the alternating current flowing through the Tate fixture's wiring creates a magnetic field. This magnetic field can induce a current in nearby conductors like the radio's antenna or power cord. This induced current then manifests as static or interference in the radio signal. Shielded cables act as a barrier, preventing the magnetic field from inducing a current in the radio's wiring. Ferrite beads, which are small, donut-shaped magnetic cores, can be clamped around the radio's wiring. They absorb high-frequency noise, further reducing the induced current. Secondly, electromagnetic interference, or EMI, is another significant factor. Tate fixtures, especially older models, can emit electromagnetic radiation across a broad spectrum of frequencies. This radiation acts like noise, disrupting the radio's ability to receive and decode the desired signal. EMI-shielded ballasts are designed to contain the electromagnetic radiation within the ballast itself. They have a metallic casing that acts as a Faraday cage, preventing the radiation from escaping. Similarly, fixtures with built-in EMI shielding of conductive materials integrated into the housing to block electromagnetic waves. Thirdly, electrical noise on the power lines can propagate throughout the electrical system and affect sensitive electronic devices like radios. This noise can originate from various sources, such as switching power supplies, motors, or even other lighting fixtures. A power line filter is a device that attenuates unwanted frequencies on the power line, allowing only the clean 60 Hz alternating current signal to pass through. A surge protector not only protects against voltage spikes but can also incorporate filtering components to reduce electrical noise. Fourthly, wiring issues, particularly improper grounding, can create ground loops. A ground loop occurs when there are multiple paths to ground with differing potentials. This difference in potential causes current to flow through the ground conductors, generating noise that can interfere with radio signals. Ensure that all grounding connections are secure, clean, and properly connected to a common grounding point. Follow the National Electrical Code, or NEC, Article 250 for grounding and bonding requirements. Fifthly, ballast compatibility is crucial for optimal performance and to minimize interference. Ballasts are responsible for providing the correct voltage and current to start and operate the Tate lamps. If the ballast is not designed to work with the specific Tate lamp, it can generate excessive electrical noise or harmonics, leading to radio interference. Use only ballasts that are specifically listed and labeled for use with the Tate lamps you are using. Furthermore, always verify the wiring and grounding system. Check that the wiring is correctly sized for the circuit's amperage. Refer to NEC Table 310.15b16 to determine the appropriate wire size based on the ampacity and temperature rating of the conductors. Inspect all grounding connections to ensure they are tight and free of corrosion. Grounding conductors should be continuous and unbroken throughout the circuit. Consider the impact of other electrical devices. Incandescent lamps generally produce very little electromagnetic interference compared to fluorescent or light-emitting diode lighting. The type of ballast used in the tate fixture can also affect the amount of interference generated. Electronic ballasts tend to produce less interference than magnetic ballasts. Check the radio's signal strength. A weak radio signal is more susceptible to interference. If the radio signal is weak, try repositioning the radio or antenna to improve reception. Light-emitting diode fixtures are generally more energy efficient and produce less electromagnetic interference than tate fixtures. However, not all light-emitting diode fixtures are created equal. Choose light-emitting diode fixtures that are specifically designed to minimize electromagnetic interference. These fixtures will typically have shielding and filtering components to suppress noise. The process of elimination can be a valuable tool in troubleshooting radio interference. Turn off all electrical devices in the area, one at a time, to see if any of them are contributing to the problem. Once the source of the interference is identified, you can then take steps to mitigate it. Radio interference can sometimes be difficult to resolve, even with the best troubleshooting techniques. In these cases, it may be necessary to contact an electrician or a radio interference specialist for assistance. These professionals have specialized equipment and knowledge to diagnose and resolve complex interference problems. Here are some additional tips for minimizing radio interference. Keep the radio and its antenna as far away as possible from the tate fixtures. Use shielded cables for the radio's antenna and power cord. Install a ferrite choke on the radio's antenna cable. These chokes act as filters, blocking high-frequency noise. Use a power line filter to clean up the power going to the radio. Ensure that the radio is properly grounded. If the radio has a ground terminal connected to a known good ground point, consider using a different type of antenna. An external antenna may provide better reception and be less susceptible to interference. Finally, consider replacing the tate fixtures with light-emitting diode fixtures. As mentioned earlier, light-emitting diode fixtures generally produce less electromagnetic interference than tate fixtures. When selecting light-emitting diode fixtures, look for models that are specifically designed to minimize electromagnetic interference. These fixtures will typically have shielding and filtering components to suppress noise. Shielded cables typically have a metallic braid or foil that surrounds the inner conductors. This shielding helps to block electromagnetic radiation, preventing it from interfering with nearby devices. Ferrite beads are made of a magnetic material that absorbs high-frequency noise. They are typically installed by clamping them around the power cord or signal cable of the affected device. Power line filters are designed to remove noise from the electrical power supply. They typically contain capacitors and inductors that block high-frequency noise while allowing the 60 Hz alternating current signal to pass through. Ground loops occur when there are multiple paths to ground, creating a potential difference that can cause current to flow through the ground conductors. This current can then induce noise in nearby electronic devices. To prevent ground loops, ensure that all electrical devices are connected to a common grounding point. Also, avoid using multiple ground paths. If you are unsure about the proper wiring and grounding techniques, consult with a qualified electrician. They can help you to identify and correct any wiring errors that may be contributing to the radio interference problem. In some cases, the radio interference may be caused by a problem outside of your control. For example, a nearby radio transmitter or industrial equipment may be generating excessive electromagnetic radiation. In these cases, you may need to contact the operator of the interfering equipment or the local regulatory agency. Radio interference is a complex problem that can be caused by a variety of factors. By following the steps outlined in this guide, you should be able to identify and resolve many common radio interference problems. However, if you are unable to resolve the problem yourself, it is best to consult with a qualified electrician or a radio interference specialist. They can help you to diagnose and resolve more complex interference problems. Understanding the fundamentals of electrical wiring, grounding, and electromagnetic interference is essential for troubleshooting radio interference problems effectively. Electrical wiring is the network of conductors that carries electrical power from the source to the various devices and appliances in a building. Proper wiring is essential for safety and for ensuring that electrical devices operate correctly. Grounding is the process of connecting electrical devices to the earth. Grounding provides a path for fault current to flow back to the source, which helps to protect people from electrical shock. Electromagnetic interference is unwanted electromagnetic energy that can disrupt the operation of electronic devices. Electromagnetic interference can be caused by a variety of sources, including electrical wiring, lighting fixtures, and electronic equipment. By understanding these fundamental concepts, you will be better equipped to troubleshoot and resolve radio interference problems. Remember to always follow safe electrical practices when working with electrical wiring and equipment. Turn off the power before working on any electrical circuits. Use insulated tools and wear appropriate safety gear. If you are unsure about any aspect of electrical wiring or equipment, consult with a qualified electrician. Electrical safety is paramount.